Alright, let's try a couple of these on for size. We're going to take a look at the end behavior of these things. Here's my f of x, and it is equal to that. And for large values of x, f of x can be approximated by, oh, that's pretty straightforward. That's just the negative 3x cubed. That's the leading term on top, divided by x squared. That simplifies to negative 3x. And if I were to graph the negative 3x, that's basically a line that looks something like this. Something like that. And that's straight up y equals mx plus b. So here's the point that I'm trying to make is the graph might do something funky on the inside. Okay, well here's another thing we need to test out. Let's try x equals to, I don't know, x is equal to, okay, wait, where can I think of this? Oh yeah, x is equal to 0. Let's try that. If I plug in x equals 0, I'm going to have negative 3 times 0, which is 0, plus 0, plus 10, so I got 10, over 1. So I've got 10. So the graph is actually going to be on this side over here. So I'm betting that the asymptote is going to look something like this. You know what? This one's going to come... Oh, and this one's going to come like this. There we go. And as I go out further and further, it's going to get closer and closer to looking at like this asymptote right here. I'll tell you what. Why don't I prove it to you and myself, and graph that thing and see what they say. All right, let's try this. So we've got equals. All right. Here, let's see. Negative 3x cubed divided by negative 3x cubed plus x plus 10. I have no idea why this thing doesn't display nicely, but x squared plus 2x plus 1. Okay, so things are happening that are funky on the on the middle, but this thing actually did exactly what I thought it would, as far as you zoom out. And I'll tell you what, why don't I throw in the graph negative 3x there. Those graphs almost look the same. Now, granted, as you zoom in, you can tell that the green graph is not the same as the blue graph. But as you zoom out, as the thing gets closer and closer, you'll see that it actually does exactly what I thought it would. Or at least close to what I thought it would. It does do something funky over there. It actually does cross the asymptote. But really what this is this isn't necessarily an asymptote as it is more of a trend. This thing will trend towards this direction. Now, I thought for some reason it would start up like this and come down like this, but actually what it is it's going to start down like this and then kind of come like that. So here's what I'm saying is, let me just kind of make this a little prettier. If this red line were my asymptote, what I think that the graph is going to do is it's going to come from this side like that, and it's going to trend towards that red line. And then over here, it's going to come over here and trend towards that red line as well. And the reason why I can do that is because if I were to factor this denominator at least, so I've got negative 3x cubed plus x plus 10. But on the denominator side, I have, that would be x plus 1 plus 1. I see that my vertical asymptote occurs at x equals negative 1, which I agree with. But look, it actually occurs at x equals negative 1 twice, or the denominator is actually x plus 1 squared. So the vertical asymptote, since it's got an even power, what happens is will it starts and it kind of like tapers off to infinity over here, but it also tapers off to negative infinity over here, since it's got an even power. So that's basically how I can justify what the graph looks like without even really graphing it. I think that's pretty awesome.